Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this Azure Data Engineering course, and in this particular video we are going to understand what is cloud. We are going to understand the fundamentals of cloud, why do we need a cloud environment, as well as we will be understanding how many different type of components are there inside a single cloud. So let's get started with this particular video and let's get straight into the system. So the very first thing that we will be understanding is what is a cloud. So cloud computing is a revolutionary technology that has fundamentally transformed how organizations and individuals access, store and manage data and computing resources. Okay. Rather than relying on physical infrastructure located on premises, cloud computing delivers computing services including servers, storage, databases, networking, software, and analytics over internet, allowing users to access these resources from anywhere with an internet connection. Okay, so let me just first of all tell you what exactly this on-prem thing is, right? So let's suppose you are opening a company, right? And you need to create a application. Okay, let's say you need to create an application and a simple website, right? Now once you have created this application, so the development can be done on our laptop, right? The development can be easily done on our local system, on the PCs, on the laptops and everything, right? But once you have developed your application and your website, these things should be available to everyone in the world, right? So to make it available to everyone, you will have to host it somewhere, right? You will have to host it somewhere so that it's available to the world. So to do that, what we require is we require something called as servers, right? To store the data that the data that we will be producing using the, let's suppose, user interaction by using logs, right? And whatever uh, different ways. So to store the data that we will be producing will be, for storing that we will require databases, right? To make it secure, right? To, let's suppose, prevent it from some kind of cyber security attack and all those things, we will require some kind of networking thing, right? And all these stuffs. So let's suppose we did not have any kind of cloud infrastructure available for us. So after creating this application and our website, we will have to set up each and everything on our own expense and on our own premises. This is what it is called as on-prem. Okay. So we will have to buy the servers first of all, right? We will have to then manually on these servers, we will have to ourselves host the databases, right? So it will be like one other kind of headache for us, that first of all you can buy a server, you will have to add databases, then you will have to attach the networking and everything, right? So that these servers can talk to each other, right? Then you should have some kind of space where you will be handling and managing these servers, right? Again, you should have some kind of storage and all those stuffs ready for you, right? Again, if something goes down, you should have a technician who will be managing all these servers if something goes down, right? The networking of the servers, right? The handling these storage and everything. Okay, you should have a separate person to manage all these things. Then you will require a cooling infrastructure, okay, because these servers produce a lot of heat. So to manage that heat and everything, you will require a whole cooling infrastructure. So all in all, the complexity will be very high. Okay, cost again will be very high. Okay, time to set up this infrastructure and all those things, again it will be very high, as well as the running cost, the recurring cost will also be very high, right? So setting each and everything on prem just to host a simple application or a simple website can be very expensive, very complicated, time consuming, and even maintaining those things can be a very big headache for an organization. So to overcome that particular issue, what these larger companies like Amazon, so mostly we use the cloud services of these three companies. Amazon, that is AWS, then we have Microsoft, that provides us the cloud as Azure, and then we have GCP, that is Google. Okay, there are much more companies. There is Oracle, right? There is this Alibaba, right? And many more companies are there which provide these cloud services. But the top three players managing more than, I guess, 70% of the total cloud consumption are these three big players. So what they did is they said that we will manage each and everything from for you. We will have our uh, we will have our data centers. Okay, so these are called data centers. So data centers are places where a large number of servers, a large number of storage devices, networking, right? Keeping in track that all the hardware and everything, all the stuffs should be up and running. So all these things are managed by these organizations. Okay, we as a user, okay, I made this user inverted. So me as a user, I should have a laptop, okay, and an internet connection. So let's suppose this is my LAN or something. So this is my internet. So using this internet only, I can access this data center from anywhere. Okay, and there is not one single data center that is available. There are multiple of data centers that are available. So here again, if I talk about the on-prem thing, let's say if I want to maintain the replication of my data, right? Because any organization will not keep only a single copy of the data. It will replicate its data to prevent it from any kind of fault tolerance. Let's suppose an earthquake happens or a fire breaks out and this particular whole thing goes down, right? So organization will lose all the data, right? So it will it will do what? It will create a replica of this on-prem infrastructure somewhere else, in some, maybe some other place, on a rented place, or maybe if it is having some office at some other location, it will create a replica of it, right? So again, to set up, to manage, to run and do all those tasks, the cost and the complexity keeps on increasing, right? But handling all these things, right from the maintenance to creating the replica to managing it, uh, managing the available zone and all those things will be the headache of the organization. I should just have some money. Okay, I don't, and here there are multiple services for multiple use cases. Okay, so I just have to use the particular service that I require. So let's suppose I have a single website that I have to host. So on Azure, I can host it on Azure virtual machine, right? And I can use, let's say, Azure Cosmos DB to store my data. Okay, that's it. I need these two services, and these two services will be very cheap for me as compared to setting up this whole infrastructure. It will be very cheap. Okay, again, complexity is very low, right? I just have to understand basically how I can use this cloud platform. That's the only complexity, right? So complexity is low as compared, again, I am emphasizing that, as compared to this on-prem infrastructure. Cost is very low. Time to set up again is very low. We just have to sign up, right? Provide our a few credentials, and then we can just log in and start using the resources. And the maintenance cost is near about zero for me. Okay. all the maintenance and each and everything will be the headache of the cloud service provider. Okay, so this was a great shift in basically the 21st century, right? So this shift from a traditional on-prem system to remote means this cloud system is basically a remote thing, right? It is present somewhere else and I can access it sitting from any corner of the world. Internet based infrastructure and became one of the most significant technological innovation of the 21st century. Okay, then the core concept of cloud. At its essence, cloud computing refers to the delivery of computing services over the internet on as you pay basis. Means as much as you use those services, you only have to pay for that much. Let's suppose if you are, and again, if I talk about this on-prem thing, right? So this on-prem system will keep on running on a 24/7 basis. I can't switch it off, right? Because if I switch it off, let's suppose if any other team is working on that, even they will not be able to work on it and things like that. So on-prem thing will be working on a 24/7 basis. Here, if I'm using, let's suppose, a server for, let's say, 4 hours a day. So I will only have to pay for those 4 hours which I am using the server for. For the rest of the time, I will not have to pay a single penny. But again, it's not that simple. Okay, let me make this thing also very, very clear. So let's say if you have attached any kind of storage to the server, in that case, you will not be paying for the cost of the running of the server, but you will have to pay for that storage if it is attached on a 24/7 basis. Okay, so again, it's not even that simple, but again, it's not even that complex. Okay, the term cloud is used metaphorically to represent the internet or a large network of remote servers. Okay, so cloud is basically a metaphor that represents the internet or large network of remote servers. Rather than purchasing expensive hardware and maintaining it yourself, cloud computing allows you to rent computing resources from third-party providers who manages the infrastructure, the security, and maintenance. Okay, so it will be the responsibility, it will be the job of the cloud service providers such as Amazon, Microsoft, or Google, or any other third-party cloud provider to maintain that particular infrastructure, to maintain the security of that infrastructure and the normal maintenance of the servers, of the databases and all those things. Any kind of update is there, any kind of bug fix is there. So it will be the responsibility of the third party provider. If I am doing it on a self-hosted way, then managing each and everything right from the infrastructure to the security to the maintenance, updates, bug fixes and everything will be my responsibility. This model fundamentally changes how businesses approach information technology, converting large upfront capital expenditures into more manageable operational expenses. Okay, so if we are going ahead with the on-prem system, so there will be an upfront large capital expenditure, right? Again, as I told you that we will have to buy all those hardwares, manage everything, hire a team who can manage the networking, who can manage the infrastructure, the security of the on-prem thing. Here it's more of the operational thing. Whatever we require on the fly, we can use it. We can use it on the fly. If we want an other service, any other service that we want to use, we can attach it and we can start using it. Okay. The concept of cloud computing is built on several foundational technologies and principles. Cloud computing architecture typically consists of front end, a user-facing side with application and interfaces, a backend, the service provider's infrastructure including servers, storage, databases, and management systems. Okay, so basically the cloud will again have two kind of system. The front end system. So the front end system will be basically a UI, a user interface, using which the user can interact with the remote servers and the storages, the databases that are present in the other part of the world. Okay, so let's suppose this is Microsoft data center. Okay, Microsoft data center, it is there in USA. Okay, this data center is present in USA. Okay, I am sitting here in India, right? So this is Vishal, and Vishal is sitting in India. Okay, so what Vishal requires is, Vishal requires a laptop, right? And using his laptop, Vishal will go to, let's say, azure.com, right? And using the UI, Vishal will be able to spin up a server. Okay, I can host a database, I can maybe train my machine learning model and whatnot. Okay, whatever is required to me as a user from Azure, I can do all those things using this UI on my laptop, and I can spin up that resource in USA or maybe any other region which I am using. Okay, so here there are two things. So this is the front end part of the cloud, right? And this is the back end part of the cloud. Okay, this is front end and this is the back end part of cloud. Okay, these components are connected through networks, usually the internet, allowing seamless communication between user and cloud resources they access. Again, as I previously told you, that in middle, obviously I will require an internet connection using which I will be sending the request to this particular data center. That okay, you need to spin up this, you need to maybe bring down this, right? You can attach a new service and whatnot. Cool. Now let's talk about a brief evolution of cloud computing. So the history of cloud computing spans more than half a century, tracing back to the concepts developed long back before the internet as we know it today. In the 1960s, the concept of time sharing emerged, allowing users to access a single powerful mainframe computer simultaneously. Okay, so in 1960s itself, this time sharing concept emerged, where multiple users were using one single powerful computer, which laid the foundational theory of modern cloud computing, right? So talking about today's world, so that that whole data center can be compared to this mainframe computers, and the users can be compared to the multiple users who are accessing this mainframe computer simultaneously. This era saw pioneering projects like ARPANET, launched in 1969, which was the predecessor of today's internet and was explicitly designed as a resource sharing tools between different institutions. Okay, so in 1969, this ARPANET was designed, or it was basically developed as a project, which later on became the base for today's internet. Okay, the modern cloud computing era began in early 2000 with the emergence of commercial cloud provider. In 2004, Amazon launched its first cloud computing service, SQS, followed by the official launch of Amazon Web Services in 2006. So AWS, the most widely used web service or cloud service, is AWS, which was launched in 2006, which introduced Amazon EC2 instance, which is again one of the highest used cloud I would say service till date. Okay, and S3. So these are the two mostly used cloud service till date, that was launched in back 2006, around 20 years ago. Okay, these services allowed users to rent virtual computers and storage over the internet, making a paradigm shift from traditional IP infrastructure. Subsequently, other technology giants entered the market. Google launched Google App Engine in 2008. Microsoft launched Azure in 2009. So 2 years later, Google launched Google App Engine, and 3 years after AWS, Microsoft launched Azure, and other providers followed, creating a competitive landscape that drove innovation and affordability. In 2010s, the 2010s witnessed further maturation of cloud technologies, including the introduction of containerization, Docker in 2013, Kubernetes orchestration in 2015, and the emergence of serverless computing with AWS Lambda in 2014. Okay, so with time, okay, as the time grew, multiple new technologies came into picture, such as containerization. So I won't be discussing containerization in much detail in this video, but Docker is the tool using which we can containerize our application. Okay, which came into picture in 2013. Okay, then comes the Kubernetes, right? Which came. Okay, so with the introduction of the Docker, or you can say the containerization in 2013, the landscape of cloud technologies or the cloud infrastructure again changed. And with the introduction of orchestration tool of these containers such as Kubernetes in 2015, again some kind of paradigm shift was noticed in the cloud environment. And in 2014, right, AWS came with something called as serverless computing. Okay, so serverless computing basically means that the servers will only be running for the time that you need it for. Okay, rest of the time you will not be paid, or you will not be charged basically for that particular, even the servers. Okay, uh, so once your job is done, that server will again go down, and you will be only charged for, let's suppose if you have ran that server for half an hour, so you will only be charged for the half an hour of running that server. Okay, so with all these advantages, right, all these infrastructure, like less complexity and flexibility, right, it like these cloud servers, or I would say these cloud providers, grew in a very short period of time. Then in 2019, when COVID-19 pandemic in 2020 accelerated cloud adoption as organizations worldwide scrambled to enable remote work and ensure business continuity, further establishing cloud computing as essential infrastructure, right? So when in 2020, when COVID-19 hit, right, everyone and every business and everything went online, right? Everyone wanted to be safe at home and wanted to basically do a remote kind of job. So even the businesses who were earlier having a kind of on-prem infrastructure, they also tried to come on the cloud part. And even the local developers, right, they started using basically these cloud services. And that particular thing, that world moving from an offline thing to an online thing, further accelerated the adoption of cloud. Cool. So this was a basic history of cloud. Now the five essential characteristics of cloud computing. So according to National Institute of Standards and Technology, cloud computing is defined by five essential characteristics that distinguish it from traditional computing models. First is on-demand self-service. So user can provision computing like server time and network storage automatically without requiring human intervention from the cloud provider. Okay, this allows organizations to independently request and receive access to services within minutes, rather than waiting an IT team to manually set up the infrastructure. Okay, so whenever a service is required to anyone, they can spin up that particular service within a few minutes, right? Rather than requiring the IT team to first of all set up that whole infrastructure and then get it going. So user can provision it within a few minutes, right? Can provision resources like server, okay, and network storage. Here it should not be time. Okay, it should be resources like server and network storage automatically without needing even any kind of human intervention from the source service provider. Okay, again, like as we are already aware about that, using this front end back end concept, right, we can automatically launch whatever kind of service we require. We don't require any kind of human intervention, means I don't have to call the Microsoft people that okay, I need this particular server, and I need this particular storage device. No, using the UI that has been provided to me by the Microsoft people, I can spin up those services whenever I require without any human intervention. Okay. Then second thing is broad network access. So cloud services are accessible over standard networks and through various heterogeneous devices, including laptops, smartphones, tablets, and desktops. Okay. So if we are having an internet connection, I can access my cloud, my infrastructure using any device, be it laptop, be it the smartphone, be it the tablet or anything, right? You can access your network using any of the heterogeneous devices. User can access their application and data from any internet connected location, enabling unprecedented flexibility and mobility. Okay, so as long as your device is connected to internet, it does not matter whether you are in India, you are in USA, or you are in any part of the world. You can access your infrastructure, you can access your data, you can access your servers, right, which enabled flexibility and mobility. Then resource pooling. Cloud providers employ a multi-tenant model where physical and virtual resources are dynamically allocated to multiple customers. Okay. So here what happens is the single infrastructure or a single resource can be distributed to multiple users. This means, okay, let's suppose I am having a machine which is having 64 GB of RAM. Okay, let's say it is having 32 cores. Okay, it is having 32 cores, right? So me as user 1, okay, I have requested as 4 GB RAM and 2 core. Okay, some user 2, it has requested 8 GB RAM and let's say 4 core. So what these cloud providers will do, they can they can point these two users on the very same machine. So here some resource, let's say this much resource, will be provided to the user 1, and these resources out of this whole resource will be provided to user 2. Again, if user 3 wants to spin up some kind of server, let's say again 4 GB RAM, right, and 2 core CPU, so he can spin up this, but his or her server in this this whole system only, or this whole I would say this whole remote server will be there, right? The larger server. Inside this larger server, the users can spin up the smaller servers. So basically, this is what resource pooling is. That they can, multiple users or multiple customers can be allocated the resources dynamically. So let's say if now this user goes down, okay, he has stopped his resource. So again, let's say user 4 comes into picture, he can be allocated this resource. So this is how dynamic allocation basically works. This pooling of resources allows providers to achieve greater efficiency and cost effectiveness by serving multiple organizations from the same infrastructure. Okay, so I'm just giving you a basic example here. Obviously it is much more complicated than this. Then rapid elasticity. Cloud computing system can quickly scale resources up and down based on the demand, sometimes automatically. Okay, so this is basically called as scaling up and scaling down. So what this usually means, so if I give you an example, okay, so all of us watch IPL, right? All of us watch IPL. So talking about the Hotstar thing, okay, so in a non-IPL season, maybe the average viewership of Hotstar is 1 lakh per day. Okay, maybe in a non-IPL season. In non-IPL season, the average viewership or maybe the average user that comes on Hotstar is 1 lakh per day. Okay, but in an IPL season, this user base can grow as much as, let's suppose, 10 crore per day, right? So here we are having more than 1000x users in the IPL season. So if, let's say, a Hotstar or maybe Geo or Reliance, right, is having an on-prem infrastructure to manage this thing. So if in a non-IPL season they are managing, let's say, their infrastructure on 2 servers, so they will have to buy 2000 servers to manage the IPL, right? So can you just imagine the first of all the cost, then the complexity, then the manpower, and each and everything that will be required to manage 2000 servers on prem, right? So to like even to I would say to erase that particular issue, right, or to mitigate that complexity, right, these cloud providers can scale up or scale down on demand. Okay, and even this 1 crore per day footfall is, or 10 crore per day footfall is, when the match is going on. When the match is done, these numbers can drastically fall, right? These numbers will fall drastically, right? So what these cloud providers do is, and the flexibility is, that during the match I can spin up thousands of servers, right? And when the match is over, I can drop these servers and I can only keep only those servers that I require to manage these many users at one single time. Okay, so this is what this scaling up the resource and scaling down the resource means. And sometimes this scaling up and scaling down can also be done automatically without any kind of human intervention. So whether an organization suddenly experience a sudden spike, just like this is a sudden spike, right, in traffic, or periods of low activity, cloud resources can instantly increase or decrease without disrupting service, and users only pay for what they actually use. Okay, so they, here the Hotstar or the Geo will only have to pay for the time. Let's suppose they're using these 1000 servers only for 2 months, so they will only have to pay for 2 months for the 1000 servers, and the for rest of the 10 months they will have to pay for only for 2 servers. Okay, so this is again a very uh, like a very useful service, or I would say a feature that is provided by the cloud providers. Then measured service. Cloud systems monitor, control, and report resource uses for each user, enabling transparent pay-per-use billing models. This this metering of service ensures that organizations only pay for the resource they consume, making cloud computing economically efficient. Okay, so each and everything is tracked. Okay, each and everything is tracked, how much you are using, for how much time you are using, and how much you have to pay for using that particular service. So these things may make uh, the things transparent. The organizations know that, okay, these are the services that I have used, I have consumed it for this much of period of time, and this is what I have to pay. Okay, then cloud service models. So cloud computing is delivered through three primary service models, each representing a different level of abstraction and management responsibility. Okay, so cloud service provider provides the services basically on three levels. That is infrastructure as a cloud, platform as a cloud, and software, or like software as a service. Sorry, not as a cloud, infrastructure as a service, platform as a service, and software as a service. So let's understand the difference between these three. Okay, so infrastructure as a service is the foundational cloud service model that provides virtualized computing resources over the internet. With infrastructure as service, providers supply the complete foundation of IT operation, including infrastructure, servers, storage, networking, operating systems, virtualizations, and management tools. Okay, so infrastructure as a service means that these cloud providers will provide us the virtualized computing resources. Okay, so resources like EC2 instance or Azure virtual machines, these infrastructures or these services can be categorized as infrastructure as a service. They are only providing us the servers or maybe any kind of storage, right, and the operating system. Rest of the things we will have to build on top of the servers. Okay, so let's suppose I am having an Azure VM. Okay, I am having this Azure VM. So this Azure VM will only consist of some RAM, okay, some cores of CPU, an operating system, and some storage. That's it. Nothing else will be present in this VM. Each and everything I will have to make. Let's suppose if I want to host a website, if I have to run some code, whatever I want to do, I will have to do it manually. So this thing is termed as infrastructure as service. Azure is giving me just the infra. Okay. Customer access these resources through dashboards or application programming interface APIs. So I can access this virtual machine either through the dashboard or you can say the UI, or I can also access these things using the API also, giving them complete control over the computing infrastructure. However, customers remain responsible for managing applications, runtime environments, middleware, operating system, and data. Okay, so it will be my responsibility to manage the application that is running on top of Azure virtual machine. The runtime environment means the basically what environment and what things are getting run on. Let's suppose if I want to run on Python, so I will have to manually install Python on my Azure virtual machine. If I want to work on Java, so I will manually have to install Java on that machine. Okay, middleware, if I want to use any kind of middlewares, how I will handle the data and each and everything, it will be my responsibility. Real world examples of infrastructure as a service include AWS, Azure virtual machines. Okay, it's AWS EC2. Okay, then Azure virtual machines and Google Compute Engine. Okay, so infrastructure as a service is ideal for organizations that want control over infrastructure without the burden of physical hardware maintenance. So here hardware and everything will be maintained by the cloud providers. Rest of the thing, it will be my responsibility to manage it. Then if I talk about platform as a service, so platform as a service acts as a middle layer in the cloud computing stack, bridging the gap between infrastructure as a service and software as a service. It combines the flexibility and customization options of infrastructure as a service with streamlined workflows and rapid development benefits of software as a service. Okay, so what platform as a service did is it became a middle layer, okay, in the cloud computing stack, bridging the service between the infrastructure as a service, like it was not a raw virtual machine, as well as it was not a full-fledged software. It was something in between. Okay, let's say it gives you some kind of runtime. Okay, it gives you some kind of runtime. Let's suppose if I talk about Databricks, so Databricks can be considered, or specifically if I talk about Azure Databricks, so Azure Databricks can be considered as a platform as a service, that it will give me the Spark runtime, the Spark environment, along with the operating systems and everything, so that I can run my Spark code on it. Okay, so it bridges the gap between infrastructure as a service and software as a service, which combined the flexibility and the customization option of infrastructure as a service, as well as, because I did not had to manage the runtime and everything, I can deploy and I can rapidly develop on the platform as a service. So platform as a service provides not only the basic infrastructure but also manages operating system, middleware, and runtime environment that makes it easier for the developers to deploy application and build continuous integration and continuous development pipeline. Okay, So the earlier things in the infrastructure as a code, such as the runtime environment, the middleware operating system, was handled by the user themselves. Now it will be the responsibility of the cloud provider to manage all those things. Now it will be only my like my only responsibility will be to host the application and to manage the CI/CD of that particular application. Rest of the things will be managed by the cloud providers. While the platform as a service offers faster deployment and easier deployment workflows, it's it does limit customization option compared to the infrastructure as a code. So obviously, most of the things, because it is managed by the cloud providers, right? We will not have that customization option that I can do in the infrastructure as a service thing. For example, Google App Engine, AWS Lambda, Heroku, and Microsoft App Service is an example of platform as a service. So platform as a service is particularly suited for developers and organizations focused on rapid application development without managing the underlying infrastructure. Then comes software as a service. So software as a service leverages cloud computing and economics of scale to offer customers an efficient way to pay, access, use, and pay for software. With software as a service, cloud providers host applications on their servers, manage the availability, security, overall performance, and software updates. Okay, so if we are availing as software as a service, okay, so if I talk about, let's suppose this, I'm using here Notion. Okay, so Notion is giving me a software as a service. So it's the Notion's responsibility to uh, to basically host each and everything, right? Whatever things are present, or if I don't give an example of Notion, let's say if I'm giving an example of, okay, Microsoft 365. Let's suppose we are having Excel, we are using PowerPoint and all those things, right? So hosting PowerPoint, right? Managing the PowerPoint, developing the PowerPoint, making sure that PowerPoint is always available when I want to use, making it secure, and even making software updates is the responsibility of Microsoft. I am just paying to use PowerPoint. Okay, I am just utilizing the functionalities of PowerPoint. I am making PPTs, and the rest of the things is being handled by Microsoft. So that is what software as service is. So users typically subscribe to software as a service application on a monthly or annual basis and access them using web browsers or mobile application. The key advantage is that customer don't have to worry about managing and maintaining the underlying infrastructure. The provider handles all critical services. Prominent examples include Google Workspace, Salesforce, Microsoft 365, Slack, Zoom, Dropbox, and all these things are an example of software as a service. So software as a service is ideal for organization seeking ready to use solution without worrying about deployment, maintenance, and updates, right? So if I'm an organization who wants to develop PPTs, right? Or let's say I want to develop PPT, right? So I will not first develop a PowerPoint and then I will develop my PPT, right? I will pay Microsoft, who has already developed PowerPoint, right? Who is already maintaining each and everything for me. I just have to worry about developing my PPT. So that is what a software as service is. Then the cloud deployment models. So cloud computing can be deployed in different ways depending on an organization's need, security requirement, and control preference. Okay. So let's see how many different type of cloud deployment models are. So there is something called as public cloud, private cloud, hybrid cloud, and community cloud. Okay. So now if I talk about the public cloud. So public cloud utilizes the multi-tenant architecture where multiple organizations share computing resources provided by third party vendors, right? So public clouds will be doing what? As I've already told you, if I give you the example of AWS, Azure, GCP, these are public cloud providers that they will be sharing the resources, right, with multiple organizations. Infrastructure, platforms, and softwares are delivered over the internet on as you pay models. Okay. In Service Cloud, the provider manages the underlying infrastructure, security, and the compliance certifications, while customers control their data, application, and access management. Okay. So, maintaining the infrastructure, keeping sure that everything is secure, and the compliance certification, it will be the headache of the cloud providers. Whereas maintaining the data, controlling the data, maintaining your application, and the access management will be the headache of the users. Uh, Public cloud provider offer unmatched scalability, cost effectiveness as organizations avoid upfront capital investment and only pay for resources that are consumed. Okay, we have talked about this multiple times that first of all, these cloud providers or public cloud providers can give us a lot of scalability in a very cost effective fashion and in a very less period of time, and organizations saves millions of dollars because they don't have to set up everything on prem. Advantages include low upfront cost, instant scalability, and access to cutting edge technology. However, organizations have limited control and share infra with other tenants. Use case include web application, e-commerce platforms, and non-sensitive workload. Then comes private cloud. So private cloud refers to cloud infrastructure dedicated to a single organization. Okay. Here the resource sharing will not happen as it happens in the public cloud. Either hosted on-prem or third-party cloud providers. Okay, so either it can be hosted on the premises, or it can be even a third-party cloud provider which will dedicatedly provide you the resources for you. This deployment model provides maximum control and security, allowing organizations to customize infrastructure to meet the specific requirement and security policies. However, private clouds require significant capital investment for purchasing hardware, software, skilled personnel to manage the infrastructure. Okay, so even the on-prem thing can be called as private cloud, or even if you are managing those things on some kind of cloud providers, it can become like very costly for the organization, right? If you are doing on-prem, then we will have to purchase the hardware, we will have to install multiple softwares to do the networking and all those stuffs, we will have to hire a team to manage our on-prem servers, right, and all those stuffs. Even if you are going ahead with a third party provider, then also we would require a good DevOps team basically to manage the whole infrastructure. So all in all, as compared to the public thing, the private cloud is a much more requires much more higher capital investment. Organizations must also assume responsibility for maintaining, patching, uh, updates, and troubleshooting. So now the user or the organization will have the responsibility of maintaining that cloud, doing any kind of patches or upgrades, and even the troubleshooting will be now the headache of the organization and not any kind of cloud provider. Private clouds are ideal for organizations handling sensitive data such as financial institutions, healthcare providers, and government agencies that require strict control over their infrastructure. So, organizations like financial institutions, banks, insurance companies, and all those institutions, they usually handle the sensitive data, right? Even the healthcare providers like hospitals and all, and the government agencies will have sensitive data, and we can't take the risk, right, of leaking that particular data, right? So in that case, these organizations will go ahead with the private cloud. Then comes hybrid cloud, which is nowadays the mostly used kind of infrastructure. integrates public and private cloud environment to functions as a unified system. Okay, so hybrid cloud will be a combination of the private cloud and the public cloud. This deployment model offers maximum flexibility, allowing organizations to leverage the strengths of both public and private cloud. Applications and data can move seamlessly between infrastructure types based on requirement, cost, and policies. Okay, so based on the requirement and based on the cost and policies, we can seamlessly move and seamlessly think about if we want to host that particular thing maybe on a private cloud or on a public cloud. For example, an organization might keep the sensitive data and application to the private cloud while using public cloud for less critical workload and requiring scalability. Okay, if I talk about bank, right? So bank can use to handle, let's suppose, any kind of transactions, right? To store the credit card details, bank details, account details to a private cloud. But rest of the things, right? Let's suppose any kind of email service is there for the bank, or maybe the bank website is there. I'm not talking about the internet banking, just the simple website, right? And all these things, they can be hosted on the public cloud, right? Because these are not any kind of sensitive information or a sensitive thing that is there, right? So they can be hosted on the public cloud also. Hybrid cloud requires orchestration tools, consistent security policies, and unified management across both environments. Real world patterns include cloud bursting, using cloud infrastructure, using private infrastructure during normal operation, and scaling to public cloud during the demand spike. Okay, so in real world, let's suppose if there is something unusual spike going on my private cloud, right? So I will not be able to scale up my private cloud in a very short notice. Okay, in that case, what I will do is that I will spin up my public cloud servers, right? And I will be able to go ahead with the demand. Then data tiering, keeping frequent access data on high performance private cloud while archiving the data to cost effective public cloud. Okay, so let's suppose if my organization is saving the data from last 20 years, right? But like in a regular basis, we don't require the data from last 20 years, right? So I can archive the data, let's suppose, of last 15 years to something as a cold storage of S3, or let's say Azure ADLS, right? And rest of the things for last 5 years of data, I will be keeping it on my private cloud. So this is what basically a hybrid cloud infra is. Then comes the community cloud. So community cloud is a relatively specialized development model where cloud infrastructure is shared among several organizations and have common goal, requirement, and compliance standards. Example include a consortium of universities, government agencies, healthcare organizations that share same cloud resources. Okay, so when multiple community or multiple organizations require the same kind of infrastructure, they have the same goal, they do provide the same kind of service, in that particular case, a community cloud can be hosted. Means multiple organizations can come together and host their thing on a single cloud. Such as if there are multiple universities, right, they can come together and they can host their thing on one single on-prem cloud that is there. Okay. Similarly, government agencies, multiple agencies can use one single cloud platform. Healthcare agencies, right, multiple hospitals or maybe multiple insurance companies can use one single cloud and things like that. Okay, community clouds require strong governance frameworks which clearly define decision making process and cost allocation method. While they offer enhanced security and specialized compliance features, they require agreement among multiple stakeholders and can reduce customization flexibility. Okay, then the cloud architecture and components. So cloud computing architecture refers to the design and storage of cloud-based system that deliver computing services over the internet. the architecture consists of several critical components that work together to deliver the services. Okay, first one is cloud infrastructure. Okay, so client infrastructure. So client infrastructure represents the front end that and includes user interface applications that can be either a browser, mobile application, or client software that users employ to access the cloud services. We have already talked about the front end part of the cloud provider. This is the touch point through which users interact with the cloud. Then there is something called as hypervisors. So hypervisors are virtual machine monitors that provide virtual operating platform to users and manage guest operating systems in the cloud. They run separate virtual machines in the backend, each consisting of software and hardware, and their main objective is to divide and allocate resources among multiple virtual instances. Okay, so hypervisors are again a kind of virtual servers itself, but they will have some kind of specific operating system, and they will be maintaining the users, or they will be basically redirecting the users on the whole of our infrastructure or maybe the data center. So it will be the job of these hypervisors basically in the backend to allocate and to divide the resources into multiple virtual instances or to multiple different virtual machines that are there in my data center. Then comes the cloud servers, host application and data, running virtualized operating systems and managing computing resources for cloud services. These servers form the computational backbone of cloud infrastructure. Okay, so these cloud servers basically, the if I talk about the thing infrastructure as a service, so these are those cloud servers themselves. Okay, so these can be used for hosting our application, maybe for managing the data and doing all our compute resources, doing any kind of compute resources thing that we want to do, we can do on these servers very easily. Then there is something called as cloud storage. So cloud storage allows users to store the data that is accessed remotely over the internet. Data is automatically scaled at a runtime and can be modified, retrieved, and recovered from anywhere with internet access. This eliminates the need for organizations to invest in and maintain physical storage infrastructure. Okay, so these cloud storages, like let's suppose S3 or ADLS, right? So if we have stored our data in these storage services, we can access these storage services from anywhere in the world if we are having the internet service, and obviously if we have the authority to access them. Okay, and this eliminates the organizations to maintain and invest for maintaining the offline infrastructure, or basically the on-prem infrastructure of the storages. Then comes the networks. So networks connect the front end and back end of cloud architecture, allowing users to access cloud resources. They are highly flexible, secure, and cost effective, enabling users to connect and customize routes and protocols. Okay, so networks will enable, or basically will handle the authorization and the authentication of the users. Okay, if a particular user can access our application or not, right? If he has the access of let's say checking our database or not, and things like that. All these things will be managed by the network. Then management and security components. So these include software that manages cloud resources, provisions infrastructure, enforces security policies, monitors performance, and ensures compliance with regulatory requirements. These components are essential for maintaining service quality and protecting the organizational data. Then service availability and market leader, if I talk about, right? So AWS, so the global cloud computing market has experienced an explosive growth, with cloud infrastructure becoming increasingly essential with modern business operation. As of quarter 2 2025, The global cloud infrastructure business has reached $99 billion in revenue, growing 25% on an over year to year basis. The market is dominated uh, by three major providers, that is the big three. Collectively they have 63% of market share. First one is AWS, Amazon, second is Microsoft Azure, and third one is Google Cloud. So talking about AWS remains the market leader with 30% of the global cloud infrastructure market as of quarter 2 2025. Amazon or AWS maintains its positions as dominant provider through a comprehensive suite of services, strong customer relationship, and continuous innovation. Microsoft Azure holds about 20% of market, making it second largest cloud provider. Azure's strength lies in integrating with existing Microsoft product and enterprise relationships. Google Cloud command 13% of the market, securing third place among cloud providers. While smaller than its competitors, Google Cloud has gained traction through competitive pricing and advanced AI/ML capabilities. Then remaining market share is between Alibaba, that is 4%, Oracle 3%, Salesforce 2%, IBM 2%, Tencent Cloud 2%. Then cloud infrastructure provide revenue are projected to exceed 400 billion for the first time in full year 2025. Okay, with Gen AI specific cloud services growth is around 160%, right? So the cloud providers who are specifically giving us the Gen AI service, their growth is around 160% on an year to year basis. Okay, then key benefits and business values of cloud computing. So cloud computing offers organizations numerous tangible and intangible benefit that drive adoption and create significant return on investment. First one is cost efficiency and reduced capital in expenditure. We have already talked about it, right? Then comes the scalability and elasticity. Okay, again we have already talked about it. High speed and quick deployment. Then enhancing collaboration and productivity, disaster recovery and business continuity, and data security and compliance. So talking about the advanced cloud architectures, right? So beyond the traditional service models and model cloud computing involves innovative architectural approaches. So first one is microservice architectures break down complex applications into smaller, independently deployable services. Each microservice runs separately, enabling deployment teams to develop, deploy, and scale components independently. This approach is particularly beneficial for large applications like e-commerce platforms with separate services for inventory management, payment processing, and user authentication. So what microservice architecture basically is, so let's suppose we are having an application where we have multiple modules, like we have authentication, right? Then we have some kind of landing page, right? Then we can have, let's suppose, inventory page. Okay, we can then have, let's suppose, payments page, and much more pages. I'm just keeping it simple, right? So what in microservice architecture we will do is we will host all these modules on a separate server. Okay, so we will host this auth module on a separate server, landing page on a separate server. Okay, this inventory thing on a separate server, right? And this payments thing on a separate server. So what this will, and these servers will be communicating with each other. Okay, they will not be anonymous, they will be communicating with each other. Okay, so what this will do is, first of all, it will enable the deployment team to develop and deploy. Okay, like they can easily deploy these services, and they can easily make any update, any changes to these services individually. Okay. And large applications like e-commerce platforms where they are managing these services. So let's suppose one of the service goes down. Let's say this payment service goes down. In that case also, the user will be able to authenticate. They can land on my landing page, they can see the inventories. They will not be able to make the payment, but at least they will be able to see the inventory. Instead of going whole of the system down, right? Even if they can see the inventory, I'm not saying that it is good for our business, but it is better as compared to the whole system going down. Okay. So this is a kind of flexibility and a kind of benefit that microservice provides us. But again, maintaining this microservice architecture is not a cakewalk. It is very, very complex. Uh, if we are dealing with some complexity as the e-commerce platform. Okay, so it's complex to manage. Then comes the serverless computing. Uh, abstracts away server management entirely. Server still exists, but customers don't manage them. Scaling, execution, resource allocation are fully managed by the cloud providers. Serverless users uh, Serverless uses a pay per execution model, charging only while code runs, which is significantly reduced cost for bursty or unpredictable workload. Examples include AWS Lambda, Azure Functions, and Google Cloud Functions. Serverless is ideal for event-driven application and workload with variable demand. Okay, so serverless computing means that each and everything, right from scaling to execution, resource allocation, each and everything will be managed by the cloud provider themselves. We will only have to manage the code that runs on that particular we will only have to manage the code that runs on the serverless computer, or you can say serverless computation system. And this particular thing is very, very useful when there is something as event driven thing. Okay, so if I give you an example, so let's say if I want to trigger an email when user buys something. Okay, so we have to trigger an invoice. So if I am deploying a whole server, of whole full-fledged server, which is running on a 24/7 basis, and let's say my e-commerce platform is not that big that I am getting the orders in every few seconds, right? Let's suppose I sell only 50 orders in one day. Okay, my orders range from 50 to 100 orders in a day. So in that case, sending email server will run for only a fraction of seconds, or maybe for some seconds only, right? It will not run for the whole 24/7 thing, right? In that particular case, we don't have to we don't have to pay for all the 24 hours of time that that particular server is running. We can only pay for those 50 emails when when that particular server sent those mails. We will only pay for that time. So that is what serverless computing is. Then containers and orchestration package. So containers and orchestration package applications and dependencies into portable, lightweight containers that can that run consistently across different environments. Container orchestration platforms like Kubernetes manage deployment, scaling, and networking of containerized application. Containers excel at microservice architecture and applications with a consistent resource requirement. Okay, so whenever we are dealing with the microservice architecture, in that particular case, containerization and orchestration will be required, right? So platforms like Kubernetes will manage our deployment, it will manage our scaling and the networking inside my containers. Okay, so what exactly containers is, what is Kubernetes? This is not the part of this particular video, so I will be restricting to discuss that particular thing. Now the security challenge and privacy concerns. So the first thing is data confidentiality. Okay, confidentiality, okay, means the security of the data basically, okay. Data confidentiality issues represents a primary concern as organizations externalize sensitive data to third party cloud providers. Personal data must remain unreachable to unauthorized users through server access control policies and regulation. A lack of trust between user and cloud providers regarding data handling remains a major security concern. Okay. Then account hijacking is described as the most serious and pressing security threat in cloud computing. Once a hijacker compromises a user or organization's account, they can access all associated accounts and activities. Strong authorization mechanism and regular security monitoring is essential to prevent account hijacking. Then data eavesdropping poses significant risk in cloud environments as encrypted data transmission over networks can be intercepted. Organization must implement SSL certificates to encrypt data in transit, making it harder for hackers to intercept sensitive information. Then misconfiguration is one of the leading causes of data breaches, resulting from adequate security practices and poor security posture management. Cloud infrastructure user-friendly nature design for easy data exchange creates significant challenges in restricting data access only to the targeted entities. Then shared infrastructure risk result in multiple organizations sharing the same cloud infrastructure, increasing vulnerability to cross-tenant attack and data leak. The reliance on third-party providers or multiple tenant environment requires careful risk management. Then real-world application, so it can be used in healthcare, right? In education, finance and banking, retail, e-commerce, media and entertainment, manufacturing, and software development. So how they can be used? Like you can for sure read it. Not a very difficult thing to understand. Okay. So this was all about the cloud infrastructure, right? So from next video, we will start understanding about the Azure cloud platforms. I hope with this particular video, you have understood very in depth that what exactly cloud is, right? What all things what all services it provides, what all different kinds of cloud infrastructure there are, right? What is infrastructure as a service, platform as a service, right? Uh, then software as a service is, right? What is a private cloud, public cloud, hybrid cloud, community cloud, and all those things are there, right? So I hope you have learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.